This is Ryan McDaniel and Megan Corbell. We represent vehicle number 11 from Rose-Hulman Institute of Technology. As the Rose-Hulman campus shut down before we could perform testing, we are giving an update on vehicle features that were not included in our design report.
Shrike is a delta trike with a tilting mechanism developed for the back two wheels. This mechanism is composed of two horizontal bars that will slide as a parallelogram to allow the bike and wheels to tilt together. The most important part of this design is that the vertical sidebars are designed so that the wheels are in line with the ends of the horizontal bars. Without this geometry, the contact point between the wheels and the ground will shift side to side as the bike tilts. This is desirable to avoid, as it will make the wheels skid, causing increased wear on the tires and stressing the entire tilting system. Additionally, the vertical bars were designed with cutouts to fit neatly together. They also leave a space for ball bearings to be inserted in order to make the tilt as smooth as possible. As the tilting mechanism was not finished on Shrike, a simplified scale model was created to demonstrate its tilting ability. The lower horizontal bar also has a disc brake attached, used to lock the horizontal bars in place. By removing the tilting ability momentarily, riders can enter and exit the bike with ease. While useful, a trained rider should also be able to balance the bike upright on their own when stopped, such as at a stop sign.
Another project that the team worked on that we didn't include in the design report due to it not having been completed is work on our windshield. So in the past 2 years, the team produced one vehicle whose windshields were removed because they impeded foot motion when the rider was pedaling, and another that didn't require a windshield at all. Namely, this would be TBD from 2008 on the left and SumCom from 2009 on the right. For Shrike, the team wanted to produce a functional windshield that ideally would be flush with the fairing to improve aerodynamics, but ultimately a see-through portion of the fairing that would protect the rider from small rocks and debris, while also not breaking during a crash, was all that was required. The team decided to form Shrike's windshield out of acrylic. This material was selected because it can be easily shaped and is somewhat resistant to breaking. Of course, clarity is key as well. 3 manufacturing techniques were considered, along with 2 methods of attaching the windshield. The first manufacturing technique we thought of was riveting the windshield in place. This would occur after the fairing layup, as the fairing would have to exist already, and would be the easiest of the 3 methods. It doesn't require an extra mold, and the only difficulty is holding the acrylic in place while the riveting is happening. The second was thermoforming in a vacuum former. Hulman did have a vacuum former available for us to use, and with a machine designed specifically for this task, it would be the most accurate in producing the exact shape desired. The third option would be to thermoform with a heat gun. This would be less precise, but it would get the job done. However, our research found that it may cause the sheet to bulge in places or warp the visibility. The idea of bending and bolting a sheet in place was discarded, as this process would greatly involve stressing the sheet, which would make it not hold up as well during the crash. The vacuum former stands alone as the best option when regarding the end product. However, we finished the I'm restarting this. The vacuum former stands alone as the best option regarding the overall end product of the windshield. However, after finalizing the fairing, we found that the vacuum former available to the team was too small to create the windshield that we would need. So with the other 2 options eliminated, the team chose to thermoform the windshield over a mold using 2 heat guns. The mold shown on the right here was used, and the process is roughly shown on the left. For attaching the windshield, again, there were 2 methods the team considered. Notably, the windshield may be riveted in place regardless of how it was created. Since the windshield would already be formed, this method would no longer be greatly stressing the acrylic. However, the team noted that when we were drilling holes in the fairing and windshield, if any mistakes were made, especially in the fairing, the team would be majorly set back in production. And due to this risk, the team went with our second option, which was laying up the windshield in the fairing itself. This method has a similar risk to the riveting in that we would have to start over if everything went wrong. However, the team found that fixing a problematic layup would be far easier than filling the holes in the fairing and windshield. Unfortunately, the team did not have time to attach the windshield, so we cannot say yet whether or not this project is a complete success. Additionally, the team does not have an image of the windshield itself. The image below here is a side view of our fairing modeled, showing where the windshield is planned to be placed. That's all we have for this presentation. We look forward to finishing our vehicle and attending competition next year, although we are unsure if Shrike will be used at the 2021 competition.